Our next topic is electronic notation. Okay. So what is electronic notation? It's a standard notation to indicate the electron configuration of atoms and molecules. So how to represent this? So it is indicated by NL power x. Okay. So it's a shorthand notation. It consists of N indicates, we know already, it's principal axis, right? Principal axis. Next, L stands for angular momentum, right? Subshell value is indicated by L, right? So it is angular momentum. Next, so this X denotes the number of electrons, okay? Number of electrons, okay? Suppose if you take hydrogen consists only one electron. It is indicated by 1s1, means principal quantum number n. So L value is 0. So electrons revolve in the orbital in sphere shape, right? So only one electron is there. It is indicated like this. Next, helium. So n value is 1. So it is 1s2. Right? These two electrons are revolving in spin shape, spherical shape, right? Next, so it stands for sphere shapes, right? So they rotate in sphere shape. Next, suppose if you take oxygen having 8 electrons, we can write this configuration 1s2, 2s2, 2p4, right? First orbital main shell, suppose if you take nucleus, right? I am writing only short form nucleus. In nucleus we have protons and neutrons. So first orbital contains, main shell contains 2 electrons, right? Remaining 6 distributed in second orbital. So first 2 electrons, since they revolve in the shape of sphere, remaining 4 in the shape of dumbbell shape. Okay, so they occupy second orbital, first 2 electrons revolve in sphere shape and remaining 4 electron revolves in dumbbell shape, right? So we can this is called electron notation. Next, our topic is we are having 3 rules we have to follow to describe the electronic configuration for more than one electron in the atom. We have to know some principles. Those, we are having 3 principles. Those are Pauli's exclusion principle. First one, Pauli's exclusion principle. Next, Afbau. Sorry. BE. Third one, Hunds. So, so now next we are going to discuss about these 3 rules. Right, electronic configuration should follow these 3 rules. Then only it is correct. So on which basis configuration is done, we will discuss. Right. First rule is Pauli's right, Pauli's exclusion principle. Okay, I'll write and you dig it further. Right. What it is saying is Pauli's exclusion principle states that no two electrons, no two electrons of same atom of the same atom can have all four quantum numbers in quantum numbers the same, right? So all the four quantum numbers should not same. So how we will discuss? Suppose if you take hydrogen, we will discuss about helium. Helium having only two electrons. Electronic configuration we will write as 1s2. Right? It is having two electrons. So if you take two electrons of helium, suppose these two electrons having they are in principal quantum number, we write it as 1 for the first electron, second also 1, right? L value will be 0, for this also 0, because these two electrons are revolving in sphere shape, right? Next, only thing changes is in that orbital, spin it changes here, uh, not spin, ml will take. Ml also 0, so values for this orbital also 0, right? Here all the three are same. Quantum numbers, principal quantum number, angular momentum, right? So next, only thing changes is spin quantum number. Spin, so first electron will be, it rotate in clockwise direction. Second comes in anti-clockwise direction, right? So principal quantum number, n represents principal, right? Principal quantum number. Next, L represents angular momentum. M, this one magnetic quantum number. So this one says spin, right? So for helium, two electrons are having all the values same. Only thing changes is spin changes. So one revolves in clockwise direction, one revolves in anti-clockwise direction. So at last this will change the, right? Suppose if you take oxygen or nitrogen will take. So it is having 7 electrons, 1s2, so 2s2, 2p3, right? I'll take. Suppose if it is having oxygen will take 8, 1s2, 2s2, 2p4. So we'll discuss how we'll write this one. This comes under Afbau principle. So 4, p is having 3 suborbitals, right? So 2 rotating like px, py, pz. We know these orbitals. So two electrons, second orbital, first two electrons revolve in sphere shape, right? Remaining four electrons revolve in dumbbell shape. First one electron distributes in each orbital, then second comes here. So suppose if you take these two electrons, n comes equals to n equals to 2, right? L equals to 1 for p shape, and ml also 1, and spin changes here, plus 1 plus 1 by 2 minus 1 by 2. For this electron, n equals to 2, L equals to 1, ml equals to 1, and ms equals to minus 1 by 2, like this. Clear? Right. That is our Pauli's exclusion principle. What it is saying, no two electrons of the same atom can have all the four quantum numbers same. Right? At last, even though if these three are same, spin changes. Spin of the electron will be different. Right? Next, we'll talk about Afbau principle. Afbau principle states that orbitals are filled in the order of increasing energy, right? So whenever we are writing electronic configuration, so we should follow the energy levels of the orbitals, right? So it we'll discuss about this here. As we pass on from one element to another element, next higher atomic number, one electron is added every time to the atom. Maximum number of electrons in any main shell. Main shell we are having K, L, M, N, right? So how many electrons can come in a main shell? Here 2, here 8, 18, 32. So this comes based on your 2n square formula. If here n value equals to 1, n value is 2, so n equals to 3, n equals to 4. If you substitute n values, you will get maximum number of electrons occupied in that main shell, right? So uh, here we have subshells also. Suppose if you take main shell, first K shell, only 2 electrons are there. They revolve in sphere shape, right? So around the nucleus they revolve around in the shape of sphere, right? If you come to L main shell, 2 electrons revolve in sphere shape, right, like this. And remaining 6 revolve in 2 electrons in px, and then py, 2 electrons revolve in py orbital, then pz orbital, like this. This is pz. Okay. So these 8 electrons revolve in main L shell. First we have to know how many subshells are there in each. So this comes by K will have only one subshell, right? L will have two, S P means like this. Means here 1, here 3, total 4. Next M, S, P, D, N, S, P, D, F. Right? So how many electrons fit in this main shell? 2. Here 2 plus 6, 8, 2, 8, 10, total 18. Okay. Here 2, 8, 18, 32. Like this. Here 18. We leave this. Okay. Next, in the ground state, electronic configuration can be built up by placing electrons in the lowest available orbitals until the total number of electrons added to equal atomic number. So how to find energy levels of these subshells, right? To here we have to follow two general rules. First one, to find out the energy levels of the orbitals, we have to follow one rule that to find the energy level of that orbital, electrons are assigned to the orbitals in the increasing value of n plus L. So electrons assigned to orbitals of increasing value of n plus L. What n stands here? Principal quantum number. L stands angular momentum. Okay. Next, if two subshells having same L value, electrons are assigned to the first subshell with lower n. We'll discuss. Electrons are assigned first to the subshell with lower n. N value. Suppose we'll take first orbital having only spin shape 1s, second one is having 2s, 2p, third one will have 3s, 3p, 3d, right? next 4s, 4p, 4d, then 4f. So you may think that first will have this first orbital will have lower energy level, then second orbital 2s, then it is having 2p will have somewhat higher energy level, then 3s will have higher energy level. So we'll find how to calculate using this formula n plus l. First, if you take 1 is, I am taking first orbital 1 is. So here n equals to 1, l equals to 0, right? So what is the value for this one? 1 only. So it equals to 1. N plus L, if you substitute in this, so 1 plus 0, it's 1, right? If you take 2s orbital, second orbital, n equals to 2, L equals to 0. So directly you'll get 2. Here 2p, n equals to 2, L equals to 1. Total 3 you will get. 2 plus 1, 3. So previously we got here 2. Here it is 3. So from this we can say 2p is somewhat higher energy level than 2s. Right? Next, if you come to 3s, 3p, 3d. 3d will take directly. 4s also will take. So I am not going with the 3s, 3p, 3d, 4s. Okay. Right. Now here if you take n value 3, here n equals to 4, right? L equals to 2, L equals to 0. If you substitute in this formula, what you are getting here? 3 plus 2, 5, 4 plus 0, 4 only, right? So which one is higher energy level here? 3D is having high energy when you compare with the 4s orbital. Means electrons occupy first and fourth orbital. When they will not come to third 3D. So here we'll write configuration. If you write energy levels from uh, ascending order, in the order of ascending order, 1s, then you will get next to 2s, then 2p, you will get 3s, then 3p, then you will get 4s here. Why we are getting is, reason is this. So in this way we can find the energy levels. Okay, 4s, then 3d you will get, right? Suppose two L values with the same, we'll discuss one more 3s, 3p. 4p, 3d, all 3d finished, no, we'll discuss 4p, right? Principal quantum number 4, L equals to 1, right? So if you substitute in this formula, how much you are getting? 4 plus 1, 5. So you may get doubt is, both are having same energy levels. So electron comes in which orbital? Obviously, here we have to follow second rule. What is our second rule is saying? Electrons are assigned first to the subshells with lower n value. Here we have to consider n value. Which one is having less n value? That one will be occupied first. So if 3d and 4p are having same energy level, then electron comes to 3d only. After 3d, you will get 4p, right? Next, here you will get 4p, then 5s, then 4d, like this. So in this way, we can find the energy levels of the orbital. Why we got this one, right? Here, why 3d first? Why not 4p? So this is the reason why. So even though they are having same energy levels, so electrons occupy with the electrons are assigned from the subshells from lower n value. So here n value is less, here n value is more. So electron comes into 3d, right? So that is our Afbau principle. So these are our ascending order of the energy levels of the orbitals. Okay. Next we'll discuss about Hunds rule. Right. What Hunds rule is saying is electron pairing in orbitals. Sorry. Electron pairing in orbitals starts only when all available empty orbitals of the same energy are singly occupied. Right? So electrons pairing in orbital starts only when all orbitals, available empty orbitals of the same energy are singly occupied. Here, suppose if you take carbon atomic number is 6, configuration we can write as 1s2, 2s2. Here we have to follow Aufbau principle. 1s2, 2s2, 2p2. Right? So these two electrons clockwise, anti-clockwise, right? In sphere shape only. One revolving clockwise, second one comes in anti-clockwise, right? Here in P we are having three subshells: Px, Py, right? Px, Py, Pz. So one electrons occupies like this. Okay. If you come to nitrogen number is 7. So 1s2, 2s2, 2p3, 2p3 only, 703, right? So here two electrons revolve in sphere shape, one electron with clockwise direction, second one with anti-clockwise direction. So we can draw like this also, clockwise, anti-clockwise. Next, clockwise, anti-clockwise. Here three orbitals. Dumbbell shape have three orbitals like this, right? X-axis, Y-axis, Z-axis, X-axis, Y-axis, Z-axis. So here one electrons occupied by each orbital like this. So two electrons will not come in first, only one orbital. Each three suborbitals are distributed with single electron. Right? Next, if you go with oxygen, 8 electrons. So 1s2, 2s2, 2p4. Right? So we know about this spin shape. If you come to X2p4, then second orbital come like this. Okay. If you want to remove one electron, so here we need, suppose someone is trying to remove one electron from here. Someone is trying to remove this electron. So the energy required to remove this, which one is required less energy level, which one is required more energy, means this requires very less energy to remove this electron. So here suppose I am using some energy to remove this electron, right? So if I am trying with the same energy level, you cannot remove this. So you need more energy to remove this electron from the atom, right? So it is very easy to remove. Why? Because so here we have two electrons now. So we can remove this one easily when compared with the singly occupied orbital. That is our Hunds rule, right? Electronic configuration we can write for all the elements. From, suppose if we are having atomic number with high order calcium is atomic number is 20, we'll write like so 1s2, 2s2, 2p6. Second orbital having only 8 electrons. First one 2. Next third orbital starts here 3s2, 3p6. Total count here. Now you count your electrons. 4, 10, 12 plus 6, 18. So next two electrons occupies in, comes in 4s orbital, 4s2. Right? So here you don't write 3d. So 4s2 is occupied with 2 electrons.